Hi, good afternoon, everyone, and welcome to a CISQ webinar, Expecting Secure, High-Quality Software, Mitigating Risks Throughout the Lifecycle. This is Tracy Berardi speaking, Program Manager of CISQ. So today's session is going to be presented by Joe Jarzombek, Director of Government, Aerospace, and Defense Programs at Synopsys. Joe is on the board of CISQ and contributes to standards development through the CISQ program. And I know many of you tuned in today know Joe personally, so thanks for dialing in. So he's going to discuss how external dependencies create risks throughout the software supply chain, how software composition, static code analysis, fuzzing, and other forms of testing can be used to determine weaknesses and vulnerabilities that represent vectors for attack and exploitation, and how testing can support procurement and enterprise risk management to reduce risk exposures attributable to exploitable software and IoT devices. So in the Handouts tab in GoToWebinar, we've uploaded a copy of today's presentation that you can download. There's also a few other resource files. And we welcome your questions. You can submit those at any time in the questions toolbar. We'll try to address those at the end, but any questions we don't get to, we'll email you responses after the presentation. So now I'm going to turn the presentation over to Joe to get started. Joe, thanks for joining us today. I just made you the presenter, so you can go ahead and share your screen whenever you're ready.
Okay, so hopefully you're seeing my screen at this point.
Yes.
Okay, so we're actually ahead there. So I appreciate the opportunity of being able to share this message, be able to have a dialogue with people afterwards here as well. But we really wanted to help people understand that today, with all the things you hear about exploitation of our assets, that we've been realizing how it's been the software. And it's almost been that people have come to a conclusion that, well, it's software, I can't do anything about it. I say that you can actually do something. You can be proactive. You should be able to start expecting secure, high-quality software. And you do that by understanding what the risks are and then focus on how do you mitigate those, not just within the development lifecycle, but what we can actually do even from an acquisition and procurement perspective. Now, this has been a bit of a journey for myself, being not just with Synopsys, but having come out of the Department of Homeland Security, working our software assurance program, our supply chain risk management program, when I was also in the Department of Defense running the software assurance program. So having worked with industry through public-private collaboration, we understand what is being done and what can be done and now what's evolved. And it's the technologies and the processes have matured quite well over time here. And as Tracy mentioned, we're a member of CISQ. And the Consortium for IT Software Quality, we view as an important part of it because we're helping to develop standards that are actually going out from CISQ through the Object Management Group, through ISO, and these are lined up with the 25000 series for software quality. And we've been developing these that focus on security, reliability, performance efficiency, and maintainability. And in particular, the reason you should look at those is to consider this because we understand there's certain constructs within software that, if they're present, represent technical debt that should be addressed right now. It shouldn't be something that you continue to release software, and certainly you shouldn't be procuring software that has this in it. So CISQ has been an important part for our contribution, but in particular who we're partnering with, the other organizations. You see the listed partners, these are sponsoring organizations, but there's many other participants from industry. And Synopsys ourselves has been a large company, and our big part of it has been electronic design automation, semiconductor IP. But more recently, we've been recognized for the work that we're doing in software quality, software security. Both Gartner has recognized us in the Magic Quadrants, Forrester puts us in the leader wave, and this has been really as a way of moving forward is the fact that this is in our DNA, because our software and tech group has only been around since 2014, but we've already gained that recognition because of the way the company's been very aggressive in acquiring the capabilities, but more significantly in maturing the capabilities of the tools that we bring to bear on this. Because quite frankly, the issues that we face today on software security and the risks that are attributable to it have to bring tools to the table, because this is no longer something that you can do manually. It's something that in order to scale, you have to be able to automate the security. And so that's been part of what we've done to continue to evolve those and to integrate the capabilities for security automation. And we'll get in and we'll talk about some of this. And in particular, we recognize that today, our basic society, everything that we rely on for services are tied to software. And the fact that you're on the phone here, you understand that. The average citizen may see critical infrastructure, they look at the physical infrastructure, they see banks, they see telecommunications, they see power plants. But the fact that you're participating in this today, you understand that the cyber infrastructure is what enables and controls it. In particular, it's the software that enables and controls that physical infrastructure. And we're finding that these dependencies on the software-reliant information communications technology, as well as the IoT devices, they're greater than ever. And there's the possibilities of disruption are likely because software is vulnerable and exploitable. And we're already seeing evidence of this, that the loss of confidence alone can lead to stakeholder actions that disrupt critical business activities. And quite frankly, it's becoming even more an ever-connected world, because what used to not be connected is now connected. It makes it easier, it's more efficient, but the challenge is that we're finding is that organizations need to be expanding their IoT efforts, need more comprehensive software security to address the weaknesses resulting from these vulnerabilities, as well as the lack of cyber hygiene and the lack of caution among those who are developing and using the IoT devices. And again, IoT is primarily all about software. Even if you look at 5G, as we look at moving networking capabilities, it's all software enabled and software controlled. And this is great for society. It's great for everything that we do. Challenge is we're getting more cyber risk and there's more consequences in these IoT solutions. And it's simply because we've been creating more attack vectors. And these edge devices, it ranges from device impersonation to snooping, tampering. The IoT platform itself is subject to hacking. The enterprise is now subject to business and mission disruption and espionage, fraud, financial waste, all through the software. And as we move forward with IoT, as we move forward with 5G networks, the challenges that we talk about today are just magnified because we're expanding the use of it. And there's a fundamental message here. If you cannot afford to protect your IoT and the software that's running it, then you cannot afford to connect it. And the reason I say that is because the cost of recovering from exploitation far exceeds the cost to protect IoT and the software that enables and controls it. And we're finding a lot of people making arguments, but it's a very expensive device, or I should say, inexpensive device, so why should I spend a lot of resources on protecting it? It's because those devices now have access to the things that you really care about. So again, the cost of recovering from exploitation far exceeds the cost to protect IoT. And we're seeing further evidence of the fact that there's lack of security without liability, and the growing number of IoT embedded devices in everything that we have, from applications to smart homes, smart cities, healthcare, medical devices. All of this is now software-enabled, software-controlled. And the reason we care, sloppy manufacturing hygiene is compromising our privacy, our safety, and our security simply because they're trying to get things to the market faster. And this is where people have to understand risk exposures and risk management and risk identification, because often in the development life cycle, people might identify risk if they actually knew what they're looking for, but they often don't take action because it's not actually their risk. They're passing on risk in the form of technical debt. And these IoT risks really provide source vectors, not just for financial exploitation, but we're finding that they're source vectors that lead to beyond the normal cyber exploitation, they're actually leading to physical harm. Cyber exploitation with physical consequences and increased risk of bodily harm from these hacked devices. So this growing dependence on these external third-party suppliers are putting our enterprises, our users, more at risk simply due to exploitable software. And this is where we start finding evidence of it. In 2016, the Bar Group did a survey of engineers who are producing these IoT embedded devices. And this was a survey of over 2,400 engineers from around the globe of their companies who produce these. And the survey was finding these, that they said engineering community concerns are poorly designed embedded devices can kill. And they're saying that about their own products. Security is not taken seriously enough. Proactive techniques for increasing safety and security are used less often than they should be. And this is coming from those who know that they could be doing more, but they're not in the environment within the companies that allow them to do that, to take advantage of the safety and security practices that could be taken advantage of within the development lifecycle itself. And the overall concern here is the shifting concerns for business. And there's basically, it's a shift in liability. And there's the understanding. For years, we've always been focusing on quality. And you need to continue to do that. But what happened in the late 2000s, we were seeing more of a focus where people started looking at security as well, looking at quality and security. Today, it is now about quality, security, safety, and privacy as well. And you're familiar with me, the changing laws, the statutory regimes are changing, they're evolving. And what happens is that when industry is not to be perceived to be self-regulating and bad things continue to happen, citizens go towards their legislative bodies and said, you've got to do something about that. So a lot of this is a reaction when you see new laws being attempted to be passed and they're now coming down on it and industry saying, oh, this is too much. It was a chance that industry could have been doing this more, but now it's almost an overreaction that we're seeing both from the legal side of it, but we're also seeing insurance stepping forward in this. And that's going to be one of the things that changes this quite a bit, because insurance is no longer about simply insuring things they didn't know about. They're trying to quantify the cybersecurity risk. And this is where we want to bring in the concept of software supply chain management. It really enables enterprises to control the risks that are attributable to exploitable software. Now, everybody has a supply chain. And I say that even though people may not fully recognize that. But you first have to understand that everyone does risk management. At the enterprise level, we do risk management because we've got to worry about regulatory compliance, a changing threat environment. We make business cases. Even when we know we've got fundamentally unsecure or unsafe products, we don't do a wholesale replacement. We have to, over time, replace the things to be able to make it more safe and secure. But in all cases, when we choose to update, we tend to turn to our purchasing organizations who are looking at, do we buy it? How are we going to be sourcing that? But the purchasing organization is turning to a supplier. And that supplier could be in-house. It could be somebody who's simply turning to someone else is doing that. But it's really an understanding that a supplier is really managing a supply chain to get capabilities to you. Your in-house development may be part of your supply chain. But in most cases, even your in-house development is using open source libraries, or they're using even libraries from a sister division. And we're finding that there's reuse of software. And the challenge was the software was developed under a regime that wasn't thinking about security or safety. And just because software worked in this one environment does not mean it's fit for use for another environment. And that brings in the whole case of who's making risk decisions, and particularly who's determining fitness for use or what is technically acceptable. And at the end of the day, asking yourself, who owns the residual risk from tainted and counterfeit products? And I'll get into what I mean by that more. But ultimately, the end user or the end user enterprise is the one who owns the residual risk. And so if you're not taking action to understand your risk, you can't mitigate that risk. So we want to help people understand, first of all, what that is. And within the IoT supply chain, we're finding that mitigating third-party risk attributable to software is a key determinant here, because we have increasing dependence on globally sourced devices. And with that, I said we have varying levels of development and outsourcing controls. We lack a transparency in the process chain of custody. Most people don't even understand who's involved in that supply chain. And there's varying levels of acquisition due diligence. We're literally finding that there are people involved in the supply chain who we wouldn't let into our own facilities, but it's somehow okay and acceptable just to accept their software and plug it into our enterprises. And what we're finding is that there's residual risk that's coming from these tainted components. When we talk about tainted components, we're talking about components that may have malware pre-installed, that may have exploitable weaknesses or known vulnerabilities pre-installed. These are already in there. And even with malware can get into products without malicious intent, because we find that developers will download open source components or bring in things that they were unaware that had either malware, exploitable weaknesses, or known vulnerabilities in it, simply because they weren't testing for that. And the growing sophistication among our adversaries, the internet has enabled them to probe us remotely. And quite frankly, the supply chain attacks are the ones that have become the most popular, because supply chain attacks can exploit the products as well as the processes, because the suppliers are not necessarily focused on the same safety, security, and privacy issues that you are as the end user. And so this is a way of understanding what's in my supply chain. But that's what we're finding today, is this increased risk from our supply chain. And the majority of breaches, we're finding that the root cause is not necessarily the things that make the news, because data breaches make headlines all the time. But the cause of a specifically unpatched vulnerability or gaining access to an exploitable weakness and exploiting it is not what makes the news. And depending on the sources you've got, Carnegie Mellon talks about 84% of the breaches originate at the application layer. And we've got SANS saying 84% of all cyber attacks happen at the application level. NIST was saying 92%. We go on and on talking about it. Really all comes down to the fact that there's multiple sources of evidence that says it's the application software that represents the vector of attack. And yet we're finding that most enterprises lack sufficient capabilities to actually take a look at it, and let alone know that they should be looking at the application software, because it's the data breaches, they exploit vulnerabilities and weaknesses that represent the root causes from insecure software. And this is a supply chain issue. Now, there will be people who will say, no, it's because people are clicking on emails that have links to places. But simply, if you look at the anatomy of when somebody has a phishing attack, yes, there's a social lure. Typically, it's referring to some recent events or some, and there's an exploit link in the email, and you're asked to click on that. Well, that's the lure that comes with it. But if you take a look at how it actually takes advantage, it's basically exploiting a known CVE, a known vulnerability, or it's exploiting an exploitable weakness that wasn't previously reported as a vulnerability. But in all cases, this is what we're finding, is that that's what allows the exploit code, the payload, to be delivered. Not simply because somebody clicked on the link, because if you had not had the known vulnerabilities in there, or particular exploitable weakness, they could be clicking all day long on it, and it's not allowing the payload to be delivered, because the payload takes advantage of those known vulnerabilities. Yet we're somehow blaming our employees or blaming our relatives for clicking on links when it's not their fault. It's the fault of the software that enabled the payloads to be delivered. And we hear a lot about trustworthiness, and I actually prefer the one that comes out of the Industrial Internet Consortium, because they look at trustworthiness from a broader perspective. And it says within an industrial IoT device, trustworthiness is the degree of confidence that one has that the system performs as expected in respect to all key system characteristics. And that's associated with safety, resilience, reliability, security, and privacy. in the face of environmental disruptions, human errors, system faults, and attacks. It's a big order, but when you take a look at saying we're focused on that, we are not deploying our software in a benign environment today. So they take a look at it from full perspective. Now, a lot of people have understood that software is fundamentally flawed. And so they now take these external views and say, we've got to be able to put up a perimeter. We've got to have a firewall. We've got to have a DMZ. We've got to put in intrusion detection systems or intrusion prevention systems. You know, some people just pray a lot that they're not going to come after you. And at the end of the day, I got to ask you, how's that working for you? Because we're finding that while it's necessary to do these things, they are not working. Because the bottom line, while these are good, they're designed for known threats, but the reality is you cannot control threats. Threats are going to not just continue to be, they're going to continue to grow. But what you can focus on is your attack vectors, your attack surfaces. These are things that you actually control. So why not focus on that as opposed to saying there's a lot of bad guys out there? Yes, and that's going to continue. So how do you understand your attack surfaces and the attack vectors? Now, we know everybody does security. Everybody does different forms of security, but at the end of the day, they're still saying it's not working for us. Why is it not working? Well, now I'm referencing some things that you may have heard of, like cross-site scripting, SQL injection attacks. What these are types of attacks that go after exploitable weaknesses in software. Now, you notice we've got codes here. CAPEC for common attack pattern enumeration, as well as CWEs, the common weaknesses. Why do we care about CWEs? Well, so long as we have these exploitable weaknesses that exploit targets or vectors, these represent vectors of future zero-day attacks. And they're then cataloged as CVEs because we put out a patch against that. And we're almost like always wanting to blame somebody else and saying, oh, woe is me, I'm a victim of a zero-day attack. Well, that's publicly admitting that somebody else is more committed to finding your exploitable weaknesses than you are. Because quite frankly, you own these CWEs. They're in your networks, they're in your systems today, and they're all discoverable. In fact, 2/3 of the CWEs are discoverable at the code level. Now, obviously, that means 1/3 of them are at the architectural and design level, but the vast majority of them you can find by running just the right tools. And static code analysis is one of the best ones in helping you understand common weaknesses. Now, the challenge that we find is a lot of people don't understand who's doing this, and quite frankly, you got to understand, there's over 300 products and services from over 152 organizations in 25 countries that report out CVEs. Pick one. You need to be using a tool that's looking for known vulnerabilities, because with those come associated patches. But there are vulnerabilities and there's weaknesses. What's the relationship? Because some people want to interchange these, some people want to call everything a vulnerability, but I'm going to tell you that actually everything would represent, in these categories here, represent weaknesses of which vulnerabilities are a subset, not the other way around. And we've actually used this as a way of helping people understand the differences between CWEs and CVEs, and right in the middle are zero-day vulnerabilities. These are actually codified in standards. ITUT, through their Cybex 1500 series, actually uses CVE, that's 1520. The CWE is it's X.dot 1524. CAPEC, the common attack patterns. ITUT is X.dot 1544. And these are also used in this space. So it's a matter of bringing in the right tools into your test regime to be able to understand them. You can get a lot more information about these. You can go to the MITRE websites, you can go to the ITUT websites to be able to gain more insights about what are CVEs and what are CWEs. And the key to understanding these and why it's important, with all the CVEs, let me say over 99% of them, when you post a publicly known vulnerability, with it is also posted the patch that you can install. With CWEs, it identifies the exploitable weakness, and different tools will define what is the recommended mitigation to address that weakness in that software. And again, the zero-day vulnerabilities really come from exploitable weaknesses that somebody else has basically found because it wasn't previously reported as a known vulnerability. They exploit it, and then it becomes a CVE. And both CVE and CWE can be used to assess the software maturity. And these are questions that you should be asking your development teams or your suppliers. You know, are the commercial open source applications being used? Are they using CVEs and CWEs? Are any component libraries incorporating the system? Do they have CVEs or CWEs? Have pen testing tools teams found any CVEs? Does the project team monitor for advisories? Do projects utilize the scoring systems associated with both CVEs and CWEs to prioritize and remediate those risks? You understand, if you've never been asking this of your development team, or if you've never been asking this of your suppliers, why should they care? Because if you as the end user, or the end user enterprise, or the acquiring organization, if you haven't asked that, you're basically saying, we don't care, we don't even know about that. So why should your suppliers care? And that's why it starts to become an understanding that we need to become more demanding consumers of the software that we're bringing into our networks. And what I found in virtually every organization I've ever talked with, they have their form of products that have been whitelisted, or their approved products list, or their assessed and cleared products list. But every time I ask the question of, have those products that are on your list that's been approved, have they been tested for exploitable weaknesses, CWEs? Have they been tested for known vulnerabilities? Have they even been tested for malware? And I will tell you, I get blank looks. People don't know how they got on the approved products list. And it's almost like it's fancy marketing brochures and stuff. As a minimum, I'm really encouraging organizations says, before we put these products on our approved list, we need to have them tested, either independently tested by someone else, or we need to have somebody inside our organization testing these products before they go on there. We need to understand our risk exposure associated with these products, not just what their cool functionality is. And ultimately, software development has become more challenging. We know that there are new attack vectors that are being embedded every day. They're brought in through embedded IoT devices, through cloud, through mobile, through open source. We know that there are shorter product life cycles. We're going to get through this as well. We'll talk about, but the point is the fact that you use Agile or continuous integration, continuous deployment, or DevOps, or hopefully you're even thinking about DevSecOps, containers with cloud computing. All of this has created more challenges for our organizations. And so I'm not saying it's gotten easier, but I am saying without bringing automation to the table, that challenge has gotten out of hand for most organizations. And today, software is assembled. This is no longer I'm building my own software. You're basically bringing it in both within the development life cycle. They're bringing in components either from open source libraries or from libraries within the company. And they're basically just assembling these together. And there's little new code that's actually being introduced. This is both in our development shops as well as our supply chains. And part of that has been through that third-party software. In fact, today, up to 90% of an application consists of third-party software. And that's not a bad thing, because actually through software engineering and systems engineering, reuse has always been considered a good thing. The challenge is when you're reusing components that are not fit for use for the new environment, that creates a bigger challenge. And as evidence, we've looked at this. Sometimes it's only down to 10% of first-party code, custom code, that we've actually developed for this application. Most of that comes in from that open source software or in some cases, using components of commercial off-the-shelf that's been internally developed. Do you actually trust what's in your third-party code? We spend a lot of time testing the software that we've developed, but are you testing that third-party code? If so, how are you testing it? What are you testing it for? And that's where we really want to talk about what is the value of software testing, because it really enables insight into the risks that are attributable to exploitable software. It gives you the insight that is necessary for risk mitigation. And reason we want to focus on that is because of the fact that software is buggy. It's just a matter of a question of how many exploitable weaknesses and vulnerabilities are in your software and your systems, your devices. Input processing can be exploited. In fact, any software processing input can be attacked, either network interfaces, device drivers, user interfaces, it goes on. And we should recognize the fact that today, hackers are using fuzzing as a way of getting into us. They're fuzzing our systems, they're fuzzing our networks, they're finding out what the weak points are. They're determining how resilient is a system. And if they're doing it, are we doing that inside of our test regime? Fuzzing has been out there for years to help people understand the reliability of a product or the resilience, but it's actually a great thing for understanding the security posture of particular applications. And so there are different techniques to address the different risks that are out there. Static analysis has been really helpful in finding common security weaknesses. These are the CWEs, that we know about, SQL injection, cross-site scripting, buffer overflows. These are really great for proprietary software, what you're doing internally developed when you've got access to source code. Software composition analysis is very significant specifically for open source software because it finds those open source vulnerabilities, the CVEs, to detect known vulnerabilities. It works throughout the full software development lifecycle. It helps you identify new vulnerabilities as they do come up. And yes, new vulnerabilities do come in because we can talk about the concept of code decay because of the fact that software, even when it was deployed, they didn't detect all the CWEs that later became vectors of attack that now new CVEs were generated. And so that's very good. Software composition needs to be in that. And certainly fuzz testing and interactive security testing is best for applications such as web applications. And so we've put that within our suite of tools of bringing these together through Coverity, Black Duck. And Black Duck now does both source code analysis as well as binary analysis to help you find, in open source, those known vulnerabilities. And Defensix as a fuzzer and Seeker as interactive security testing has been very useful, especially, like as I mentioned, with web applications. And there are many lists that help you get started. Many of you are familiar with the OWASP Top 10, the SANS Top 25, the Object Management Group that we're with CISQ. We put out the Automated Source Code Security Measures, and we also have other reports such as the Verizon report that comes out. These are just ways of getting started, but I suggest to you that as an organization, you don't want to just rely on somebody else's prioritization of what's important, both in terms of CVEs as well as CWEs. Instead, we want to be able to say, if we're testing for things, we should say, what CWEs are most important to us? There's through the scoring system, we can actually use CWSS to help prioritize which weaknesses are most important, because they put our products that are deployed in certain environments, put the users most at risk. So let's look at those. And knowing which CWEs are most important, we then want to identify which techniques or which tools do we bring in so that we've got adequate coverage, because as I mentioned, not all tools cover the same thing, so you want to be able to do that. And not all tools have the same capabilities, but they also look for different things. It's just a matter of prioritizing what's important to us based on the technology we're deploying in the given environment. And software composition analysis is something I'd really like you to better understand, because I know a lot of organizations have yet to really adopt that. And it provides a way for vulnerability assessment, but also it gives us a way of better managing our licenses. Many of you are familiar with the fact that there are some very restrictive licenses in the open source community. And by helping people understand if they have software that might have a restrictive license, such as copyleft, your developers need to understand that, because if it's going into software that you're intending to resell, you have to understand that copyleft says, yes, this is free software, but if you use this in your new software, then your package also becomes free and open source software. Not something you want to explain to your CEO for a package that's been something you've been selling for a while and your customer discovers that. But more importantly, software composition analysis gives you a software bill of materials. It's a good way of identifying risk and managing the risks that are associated with that software. In particular, I think of software composition analysis as a good way of giving us code genetics. It gives a way of helping you understand your applications, because that application could be made up of proprietary code, open source components, and the way that it's configured, and therefore the behavior. So it's a very good way of determining risk that you may not have been already leveraging. And for us as a company, I will tell you that software composition analysis helps us more than just with our development teams. It's actually something that's helped us with our IT security. It's helped us with purchasing. It's even helped us with our export controls and compliance because of the licensing and the IP that goes with that. It is an all-around way of helping multiple organizations who have different priorities, how they manage risk within a company. And I know that there's a lot of people who will have heard the story that says, well, yeah, we understand, but software security, that's expensive. Or software security, that takes too long. We actually have case studies that demonstrate just the opposite. In fact, Forrester did a case study using two of our tools, specifically Coverity and DefenseX, where they did the total economic impact of using these software, these tools for a given client. In this case, they were looking at it, and the findings were, by using these tools, while it was an upfront investment, it actually improved their product quality and security. It avoided remediation expenses in 8 different code bases of 1.5 million lines of code each, saving over $3.8 million. It lowered their defect density within its own code base, therefore preventing future costs and allowing error-prone code going forward and being reused, because we find that when you've got one component that works here, you reuse it in other products as well. More significantly, Forrester reported it reduced the time to market. By using fuzz testing and static analysis, it reduced product release cycles from 12 to 8 months. It decreased the time to detect and remediate defects and vulnerabilities. It prevented the high-profile breaches, and the ones that kind of put your CEO in the news. But it mitigated the costly post-deployment malfunctions. We all know that users hate the vulnerabilities, and even though it's on their side. Well, it turns out developers, it's really bad deploying products with known vulnerabilities and exploitable weaknesses, because it's going to cost you even more to fix those after you've deployed the system. So the numbers actually speak for themselves. Anyone who tells you security costs more or takes longer is somebody who's never done it, because the evidence speaks the opposite of that. This tells the story that by incorporating security upfront, building it in actually saves you time and saves you money. And that's why we've put together our software integrity toolkit. As I mentioned, there is no one process or tool that fits all applications, and certainly there's things to use in different phases of the life cycle to help you out. We've got a lot of attached material that goes with this, that goes through how and planning, designing, implementing, verifying, releasing, how different tools, different procedures actually help you do your job better. And it's simply a matter of applying the right process, procedures, or tools at the right time. And in all cases, we offer training to help people get started, to help people actually build their own security programs. And therefore, what we've had within our portfolio, the integrated tools, and what I really appreciate what the company's done is not only bringing those tools on board, but they've now continued to mature those tools, and now they're integrating it within the output. So you can get a single output running multiple tools. So it helps you in sense making to understand what your risk exposure is with recommendations about where to focus on it. There's also managed services, the professional services, and this all the way to strategic planning to help you get started in this. So it's the complete package is the way the companies put this together, both helping us internally, but also helping our clients. And so the overall message of this has been software supply chain risk management is more than just about the development side. It's important that if you're acquiring software or software-enabled capabilities, that you understand what your developers are doing. But when you're not the developer yourself, you actually can take control of this. Procurement requirements, independent testing and certification. One of the most recent examples that's come out through the Department of Defense is where DoD and the intelligence communities put a focus on to deliver uncompromised, where it adds security of your products and services to existing evaluation criteria that's used on cost, schedule, and performance. And that's very important because, and it's at its roots. There's a MITRE report to deliver uncompromised, and what that's doing today, it's driving changes in the law as well as our acquisition and procurement policies and practices. There's some fundamental recommendations that came out of there, but I want to draw your attention to the middle point there, because it's really saying that we need to address the full span of software vulnerabilities through these different measures throughout the full life cycle, continuous security and risk reduction practices. Determine where and for what programs or missions, and it's even recommending that you have the software bill of materials to be able to use this documented secure software development lifecycle. Having the software bill of materials enables you to take control of your own risk, because when new vulnerabilities are reported, if you don't even know where to look, it's not surprising that we're still finding evidence that those old known vulnerabilities for which there's an associated patch remain unpatched simply because people didn't know where the vulnerabilities existed. So I do highly commend the report that came out, and I recommend others take a look at that. But we wanted to help people get started with that, so we actually have sample procurement language that organizations can use. We give it away for free. The URL is listed here. But what that does is address product development, specification, and policy. It's looking at, do your developers, do your suppliers do these things? What's the security program that your suppliers have? What system protection and access controls do they have? What type of product testing and verification do your suppliers do? And it looks at deployment and maintenance. And I will tell you, one of the organizations who picked up on that quite quickly was through the financial sector. In fact, the Financial Services Sector Coordinating Council for Critical Infrastructure Protection and Homeland Security actually put out a buyer's guide back in 2016. And in that cyber insurance buying guide, they actually had the full list of software supply chain cyber assurance, the procurement requirements for your supply chain. And they were acknowledging the fact that you can't really expect to collect on cyber insurance if you've not invested in cyber assurance. And if you looked at the requirements, their procurement requirements for when they're dealing with their suppliers, the financial sector came out with the exact same things I was just talking about that we have as sample procurement language that you could use in your own organization. Product development specifications, security program, system protection and access, product testing. The product testing is the same types of stuff that we've been talking about here. It's the type of testing that we've been working with Underwriters Labs, who now has their cybersecurity assurance program. And the cybersecurity assurance program is really designed to help people seek someone else to do independent testing. And the Underwriters Labs actually certifies products against them. And getting off the stage here, I really want people to understand that software security initiatives are a journey. You can't turn on a dime. We understand that most organizations are still at a point of being compliance driven. There's some customers saying you got to do certain things. That's low-level testing. They do some pen testing to find these vulnerabilities. But then they start to scale. They start applying this to all of their products. And they're augmenting internal teams with external resources for scalability, because you just can't go out and buy all the talent that you want to be able to do this. So you can go to professional or managed services. They identify and prioritize the vulnerabilities for remediation. Again, when you first get started, you can't fix everything, but you should have a means for prioritizing that. And then integrating this with DevOps specifically so that you can now start looking at having a DevSecOps program. And then finally, more mature, they've got programmatically managed risk across all software release cycles. They're driving efficiencies through the software development lifecycle integration, and there's a purposeful blend of automation and manual testing processes. As I mentioned earlier, many of these exploitable weaknesses are at the code level, and certainly tools will help you do that, to understand that and actually identify what the mitigations are that go with that. Things that are at the architectural and design level take some manual processes to go in that, and being able to have some of the right people take a look at that. Ultimately, we understand that a lot can be done. We should start changing our consumer mindset so that we are now expecting secure, high-quality software, because we can do that. We actually understand what makes it happen. It's now just more of a willingness. And this is no longer a technology issue. This is a leadership issue. And it's a leadership issue both on the developer side, but when we start having a consumer side that is more demanding, when we start expecting it, and we have these measures that we can measure the software against before we procure it, that starts changing what's happening in our supply chain. So I do appreciate the opportunity of coming out with this. And Tracy, I was wondering if you've got any questions.
Thanks, Joe. Really good presentation, as always. Yeah, now's a great time if you have any questions. There was one that came in early on from our friend David Eddy, who I learned he coined Y2K. I had a nice chat with him a few weeks ago.
Okay.
Yeah, I'm not sure if you see it in the questions box. Are IBM mainframe applications running on Z/OS operating systems considered to be at risk? He's kind of joking with you.
Well, you know, the idea of security through obscurity isn't really working these days, is it?
I guess we'll give folks another minute in case there are other questions. And just a reminder too, in the handouts tab, you can download a copy of the presentation, and we're going to be posting the video recording of this up on the CISQ website and on our YouTube channel. Oh, David said, I'm not joking. And I wanted to mention, next month, on October 16th, CISQ is hosting our next Cyber Resilience Summit. So it's Tuesday, October 16th at the Army-Navy Country Club in Arlington, Virginia. Joe's going to be leading a panel on supply chain risk management, and he mentioned that Deliver Uncompromised report that MITRE put out. And Chris Nissen, the author of that report, he'll be on the panel. So if you are in the DC area and interested in these topics, we have a good program coming together. And you can, if you go to our site, it-cis.org, right on the homepage, there's a link to the event. But I think that's it for questions, Joe. I think we can wrap up, and thank you again for the webinar today, and thanks for everybody that tuned in. I hope you have a good rest of the day.
Yeah, and feel free to follow up with questions as far as some of the references, or if you need more information.
Okay, thank you. Bye now.
Thanks.